Okay, good morning. This is Professor David J. Delos Reyes. Okay, my topic for this session will still be a long video format discussion, and this will be a continuation of college algebra. The topic is actually the so-called application of linear equations for the solution of the so-called worded or verbal problems. Okay. So this will now be college algebra lesson number 72, applications of linear equations and the solution of the so-called worded or verbal problems. This is actually an SAT or CAT topic. Okay, let's proceed. The subject matter for this morning will be college algebra lesson number 72. Okay, the title of the topic will be applications of linear equations for worded or verbal problems. Okay, and the number one topic under verbal or worded problems is the so-called number problems. There are so many variations of problems under verbal or worded problems, but for tonight, we will be discussing the solution of number problems. Okay, let's proceed. For the solution of application of linear equations, okay, we need to translate some keywords or phrases. Keywords or phrases are actually a group of words that, what you call this, form a concept. Okay, so for number problems, let's try to bring out an example of the so-called translation of keywords and phrases to solve a number problem. Okay, I will try to give you example number one. So, it's a must that we should understand an English-oriented explanations because we are exposed to the whole world and not all are actually speaking English. So, pardon me for telling this one. This is English-oriented subject matter or lecture. Okay, example number one. The sum of a number in 13. Okay, this is a, what they call this, words or phrases. Okay, the sum of a number in 13. The problem is asking translate. Okay, to translate this into the, what they call this, algebraic expression. Okay, it will be something like this. We let x be equal to the number. Okay, so if we try to translate these words or phrases, the translation will be x plus 13. Okay, the sum of a number in 13. The number is x, okay, and the pure constant is 13, and the problem is telling sum. So if we try to translate these words or phrases, the translation will be x plus 13. That will be the answer. Okay, at least we know how to understand English, right? Okay, so this is English-oriented lecture. Okay, example number two. A number increased by 15 is equal to twice the number less 40. Find the number. So this is now an actual verbal worded problems under number problems. Okay, I will try to repeat it. A number increased by 15 is equal to twice the number less 40. Find the number. Okay, so if you are on the SAT or CAT exam, okay, at least you know how to understand the words or phrases of the problem. Because in the formulation of the algebraic equation needed to solve the problem, okay, it depends on how you understood the words or phrases. If you made a mistake on the analysis, okay, in the formulation of the equation, there should be a problem because your analysis is wrong, so of course your solution will be wrong. Okay, let's try to bring out the solution of this by using the proper way to solve it. We let x be the number. You could take any variable you want, right? Let's try to bring out the translation of the keywords and phrases from the problem. The first phrase is actually the x plus 15. And the second phrase is actually 2x minus 40. Okay, let's try to refresh again the problem. A number increased by 15. A number increased by 15. So if the number is x, increased by 15, that will be plus 15. That's the translation, right? So the translation of the phrase number is increased by 15, it is this, right? How about the next phrase? Let's forget the equal first. Is equal to twice the number less 40. Twice the number less 40. The number is x, right? So twice the number, it will be 2x. It says here, less 40. So if we try to translate that words or phrases, twice the number less 40, twice the number is 2x, less 40 is minus 40. That should be the translation. Okay? If you are correct in the so-called translation, there will be no problem in the so-called formulation of the algebraic equation needed to solve the problem. Okay, let's try to bring out the algebraic equation. This algebraic expression, okay, the values that should be placed over here emanates from the correct translations. Because if your analysis of the translation is wrong, you are wrong, right? But if it is correct, you're almost 50% done. Okay, let's try to bring out the algebraic expression. We bring out or brought out these translations already, assuming we are correct, right? So if we try to bring out the algebraic expression needed to solve for the unknown, okay, I will try to replace again the problem. A number increased by 15 is equal, okay? There's an equal word over here, okay? Is equal to twice the number less 40, meaning to say, the number increased by 15 is equal to, so we place an equality sign, equal to twice the number less 40. So the algebraic expression, okay, actually emanates from the translation because we put here an equality sign. Sorry for that one. My pen is dry already. Right? The number increased by 15 is equal to twice the number less 40. Okay, we brought out the algebraic expression already. So this is now algebra, right? Algebra. Okay. So to solve for the number, we apply our knowledge on how to bring out the solution of a linear equation, right? The only unknown is x, so by using our knowledge of the fundamental operations, okay, simplification, we can solve for the problem. Okay, let's proceed. X plus 15 is equal to 2x minus 40. We'll expedite a little, we'll expedite the solution a little bit, you know. Instead of adding, subtracting from both the left and right, we just use transposition. Okay, because the transposition is faster, right? Okay. Okay. We'll solve for x. And the proper way is to put the unknown on the left hand side. So we will maintain this x here. Okay. We put this on the left. So this is now negative 2x, right? Equal to, this is negative 40, we maintain negative 40. Instead of adding and subtracting minus 15, we just transpose this to the right. So when we transpose it to the right, we change the sign from plus to minus, so this is minus 15. Okay, so we minimize a little bit on this space. But it's the same, if you subtract minus 15 and plus 15, it's the same. Okay. So x minus 2x will be negative x, and negative 40, negative 15 is negative 55. Then multiplying all terms by negative 1. Okay. Negative x, negative 1 will be positive x, negative 55, negative 1 will be positive 55, so the answer will be 55. Okay, the unknown number is 55. Okay, let's try to check the validity of the 55. We'll go back to the algebraic expression, okay? Is 55 plus 15 equal to twice 55 minus 40? 55 plus 15 is 70, right? 70. Is it equal to 2 times 55 is 110 minus 40? Left hand side is 70. 110 minus 40 is 70. So 70 is 70. It is true. So our answer is correct. It's true. Okay, that's the way how to solve linear equations by using translations and formulate your own algebraic expression. Okay, that's verbal problem. Okay, example number 2, a little bit complicated. Find three numbers such that the second is 6 less than 3 times the first, and the third number is 2 more than 2/3 of the second. Okay, and the sum of the three numbers is 172. A little bit complicated in the so-called bringing out of the words and phrases, so take it easy. Okay, take it easy. Oh, I think three numbers, right? So the problem says the second is 6 less than 3 times the first. So the one missing here is the first, right? And the third number is 2 more than 2/3 of the second. Again, on the words and phrases for third number, it doesn't mention the first. So the one unknown is still the first, right? Okay, third number is 2 more than 2/3 of the second. Okay, it doesn't mention of the first, right? And the sum of the three numbers is 172. So actually the key to the solution of the problem is it should be the first number. That will be our reference number. So on the translations, okay, first we will let x equal to the first number, right? Because from the condition of the problem, the second is 6 less than 3 times the first. Okay, 3 times the first is 6 less than 3 times the first. So meaning to say the second number with reference to the first, it should be with the value 3 times the first less 6. Okay, the second is 6 less, okay, than 3 times the first. If the first number is x, 3 times the first is 3x, right? And according to the condition of the problem, 3 times the first less 6 is the second number, right? We should be correct on the translations, because if we are wrong on the translations, okay, in the formulation of the algebraic equation, we will be wrong, because we are substituting a wrong translation. But as long as our translation is correct, in the formulation of the algebraic equation needed to solve the unknowns, we will be correct. Okay, let's go to the third. The third number is 2 more than 2/3 of the second. Okay, so when it mentions the condition of the third problem, it says that 2/3 of the second number is 3x minus 6, right? And according to the condition of the problem, 2/3 of the second, okay, is 2 more. So this is plus 2. Okay, so 2/3 of the second is actually 2 more than 2 more. That's the way how to bring out the third. 2/3 of the second plus 2 more is actually the third number. Okay, so we are correct in this, because on the first translation, we let x to be equal to the first number. And according to the given condition, 3 times the first less 6 is the second number. And for the third number, 2/3 the second 2/3 of 3x minus 6 plus 2 is actually the third number.